From its incredible launch on the 5th of May 2018 to the present day as it reached its ultimate powering down, InSight has been an incredible lander. It has peeled back the surface of Mars and listened to the planet's slow heartbeat to gain knowledge unseen by any mission that has gone on before it. It has faced adversity. From day one, Mars fought back with an unending assault to wear it down or catch it off guard. But ultimately, its contributions to our planetary understanding are irrefutable. And it did so with a surprising tool, the planet's quakes. I'm Alex McColgan and you're listening to the Astrum Podcast. Come with me and discover how InSight did what it did, as well as exactly what it learned. In this Supercut, we will explore the mission of InSight as it happened. In the early hours of the morning of the 5th of May 2018, at Vandenberg Air Force Base, Space Launch Complex 3E in California, NASA scientists waited in nervous anticipation at their computers. Outside in the darkness stood an Atlas V rocket, a nearly 60-meter tall, two-stage behemoth capable of lifting nearly 9,000 kilograms into geostationary orbit. Atlas V rockets like this one had launched dozens of times, but it was impossible not to feel a degree of nervousness with each new attempt. Last time this launch had been scheduled, it had to be pushed by several months because of a vacuum leak involving the size instruments in its cargo. Over half the missions to Mars to that date had either never left the ground or failed once they arrived on Mars. Even at this stage, there was always a chance of something going wrong. The Atlas V was here to carry InSight, a lander tasked with uncovering Mars's inner structure by studying seismic vibrations. It was not the first lander to attempt this, but it hoped to be the first one to succeed. NASA had sent 2 prior missions to Mars with seismometers, Viking 1 and Viking 2. However, Viking 1's seismometer malfunctioned on landing and could not deploy, and while Viking 2's seismometer did manage to get readings, there was no way of telling whether what it read was a seismic vibration or just the wind. This degree of uncertainty made its readings less reliable. With InSight, NASA would attempt to close this potential source of error. The signal came. Scientists received their last weather reports. Launching a rocket is a risky business. Wind speed, cloud coverage, even solar weather can negatively influence a launch. All must be accounted for. But here, they were given the green light. InSight would be launched within the hour. InSight was a meter-high, 6-meter-long lander, sporting 2 large solar panels in a similar design to the Phoenix lander. It came equipped with multiple instruments for scientific research. It carried a seismometer with a windshield and a robotic arm that would place the sensitive instrument onto the flat surface of the Martian planet. With this, it would detect the vibrations caused by quakes in the Martian mantle or by meteor impacts. Through careful evaluation of the time delay between the various kinds of seismic waves from a single event, it would be possible for scientists to piece together Mars's inner structure with a greater degree of certainty than ever before. But that is not all. Attached was a suite of weather sensing equipment to eliminate any debate as to the source of the vibrations it was detecting. Not to mention helping scientists to better understand the climate on Mars. And to give it an even greater understanding of the state of Mars beneath its surface, it carried a mole, a hammer-powered digging tool intended to burrow deep into the Martian soil and take temperature readings. A large drill would not be economical to carry, so this was thought to be a more efficient design. The better we understand the structure of Mars, the more we can learn about its formation. And with it, the formation of other rocky planets in our solar system, like our own. With InSight, we hope to learn if Earth is an anomaly in the solar system. Are many of the other planets like us? What does this say about our formation? And so, at around 4 o'clock in the morning, InSight launched for Mars, causing bone-crushing G-forces. The first stage of the rocket burned for just 253 seconds before its fuel was expended and it detached. Then the second stage, Centaur, kicked in. This burned for another 14 minutes, which was enough time to reach escape velocity. InSight had been built to resist the strain. This first stage was a success, but now it would be time for the long trip through space. It would take another 6.5 months to travel across the 484 million kilometers between Earth and Mars. These months were quiet, serene and cold as it drifted through the star-studded vastness of space. InSight's arrival on Mars would be quite the opposite experience. It was fast, hectic and hot. InSight entered the atmosphere 125 kilometers up at almost 20,000 kilometers per hour. This generated a lot of heat, roughly 1,500 degrees Celsius. Fortunately, InSight's final stage came with heat shields that were able to absorb this blistering fury. And once the lander slowed down enough, the heat shields popped off and a supersonic parachute deployed, further slowing InSight down. Yes, Mars does have an atmosphere, although it is very thin compared to Earth's standards. With the speed InSight was traveling though, this parachute still made a big difference, although it wouldn't be enough by itself to stop the lander from smashing into the planet. But fortunately, InSight had planned for this. Unlike the Mars rovers, which just had giant airbags to bounce on landing, this spacecraft came equipped with its own rockets to land. So InSight's legs sprang into position, ready for landing. Once the parachute slowed it down enough, that too popped off, leaving just the lander itself. It then used its onboard rockets to carefully reach the surface. This whole process took place over the course of 7 minutes. It touched down successfully on the 26th of November 2018. Upon impact with the surface, the rockets kicked up a lot of dust. This is not very good for solar panels, so InSight waited 16 minutes before deploying its solar array to let the dust settle. This impressive unfurling can be seen in this testing environment before it launched. On Mars, these panels generate around 300 to 600 watts under normal conditions. However, dust in the atmosphere does affect power generation, as clouds would on Earth, so this can be different every day. Let's pause now and picture the scene. The view that greeted InSight was a red desert, scattered with pieces of rock. It seemed bleak and inhospitable, but InSight would need to get used to it. This rock-strewn, flat, dusty terrain would be its home for the next 2 years, the length of its intended mission. It had no tools for moving itself around, but that would not be necessary to fulfill its purpose. Its mission was to sit, listen, and learn. It had a lot of work to do. InSight's mission to Mars had begun. Far above the thin Martian atmosphere, a strange new sight had arrived. 2 little lights twinkled in the night sky. These were not new stars. They were CubeSats called Marco A and B, and they had been following InSight for the last several months. Their mission was to relay real-time information back to Earth about whether the landing had been successful or not, and if the solar cells had deployed. The Marco mission was a technology demonstration mission, so it didn't have any scientific instruments, but rather it carried different technologies to test. These satellites were really small, only the size of a briefcase. They were the first time CubeSats had been sent into deep space, and at the time, no one was sure how well they would do. But so far, they had performed exactly as hoped for. The Marcos began listening out for UHF frequencies from InSight with the antenna on the bottom of the spacecraft, ready to transmit that data back to Earth using this bigger antenna. This big antenna operates like a satellite dish on Earth, except they designed it to be flat so it could be space efficient. Amazingly, these satellites only generate 17 watts of power, yet are able to receive signals from the surface of Mars and transmit millions of kilometers back to Earth. Of course, NASA was not going to put all their eggs in one untested basket. If Marco A and B hadn't worked, InSight would also be able to communicate with some of the other orbiters already around Mars, like the Mars Reconnaissance Orbiter. The only difference is that the Mars Reconnaissance Orbiter can't relay information back in real time. These lights would not be in the sky for long though. After performing their mission, the Marco CubeSats would fly by Mars, unable to slow down enough to enter orbit, and instead go on forever to drift around the sun. But that is not what InSight saw. InSight did not know the fate of the machines that broadcasted its messages. All it knew was that it was time to open its eyes, and maybe call to Mission Control to let them know it had arrived at its destination okay. The first thing InSight did was to send back signals to Earth that it had touched down safely. Along with that signal came its first famous image of the Martian terrain. The first image was a little messy, as it was partially obscured by dust on the lens, making it harder to see the dusty, empty desert beyond, or the orange sky. As previously mentioned, a lot of dust had been kicked up by the landing, as InSight used descent rockets to slow its fall. Fortunately, InSight's team knew this would happen and attached a transparent lens over InSight's camera to protect it. Later, InSight would remove this lens to take clearer pictures for the rest of the mission. Meanwhile, another camera pointing under the lander revealed the effects of the rockets, which had carved out mini craters under the craft. InSight deployed its 2 circular solar panels, now that it could collect sunlight without dust reducing its efficiency. From then on, it was time to work. InSight quickly began collecting data, even before deploying any of its science instruments. The first thing it recorded was the Martian wind, picking up vibrations sensed by the seismometer still on the lander. This is what it sounds like, although I should note that you will probably either need a subwoofer or headphones to hear this. This has not been sped up. These literally are the vibrations caused by Martian wind going over the solar panels of the lander. The frequency of the vibrations converted to audio. For the benefit of those who can't hear it, here it is pitched up by 2 octaves. InSight can also detect changes in air pressure. Here is the air pressure changing as the wind blows across the lander. This audio has been sped up by a factor of 100 for it to be within human hearing range. What is fascinating is that we don't just have to imagine the wind passing by InSight, as it was also able to capture footage of water ice clouds passing by overhead, visibly showing the direction of the wind. Yes, although Mars is currently a barren wasteland, there is still a tiny amount of water vapor in the atmosphere. Now limbered up, its warm-up science done, InSight was ready for the main event. One of its primary missions on Mars was to listen out for seismic activity, but its seismometer, or SEIS, was still strapped down on InSight's body. It would need to use its robotic arm to lift its SEIS instrument and place it directly onto the Martian soil. But not just anywhere would do. If it was going to settle in for a long 2 years of listening, InSight wanted to choose the best patch of ground. Something flat, with no rocks in the way, so its windshield could lie flush with the ground and provide a perfect sound barrier, providing a means for SEIS to collect its data uninterrupted. And it had a team to help it. Almost immediately after landing, InSight started collecting 3D images of its surrounding area in order to find the perfect spot to place the seismometer. Based on those 3D images, NASA actually recreated this area as accurately as possible back on Earth, even going as far as using the HoloLens augmented reality headset to match up the surface of Mars with the environment they were recreating. Once the perfect site was chosen, the go-ahead was given, and InSight carefully used its robotic arm to place the seismometer on the surface of the planet. From there, it began detecting Mars's faintest vibrations. Then it was time for the mole, and it was here that things started to go wrong. InSight's mole was a piton-shaped self-digging tool designed to dig up to 5 meters down into the Martian soil, taking temperature readings every 10 centimeters, and then extrapolating these readings to estimate the thickness of the Martian crust. A drill that could go this deep would have been too large and unwieldy to bring to Mars. The mole's internal hammer would get around this problem by hammering itself gently into the soil and having the dust of Mars fall into the hole it was forming to provide it with friction. InSight's mole could in theory reach the 5-meter depth. InSight's mole had been tested in conditions recreated to be as similar to Mars's dusty surface as possible, only on Mars itself it wouldn't dig. Unfortunately, the mole only got 30 centimeters into the dry soil of Mars before getting stuck. Scientists back on Earth scratched their heads. Had it hit a very hard rock, or was the soil simply not providing enough friction? Either way, the mole was now stuck, tilted at an angle before it had even fully exited its housing. Earth-based teams attempted to replicate the problem and look for a safe way to pick up the housing around the mole and maybe use the robotic arm to straighten its course. They had to be careful not to damage it though, as the robotic arm had not been designed for such a task. After many weeks of deliberation, they split the task and started removing the housing to better see what they were doing. Carefully, they coaxed off the outer housing, but it would be some time before further progress could be made. If friction was the problem, scientists were considering trying to use the robotic arm to push down on the soil right next to the mole, hopefully giving it the friction it needed to start digging deeper. It would take careful planning before this method could be attempted though. It was July 2019 when the housing was removed, 8 months after InSight's arrival on the planet. It would be another 3 months before their next move was enacted. Meanwhile though, things weren't all bad. Back in April, InSight had detected its first Martian quake, and this is what it sounded like. Again, the vibrations have been sped up by a factor of 60, as the frequency would not be audible to the human ear. While data like this doesn't need to be converted to audio for scientists to use it, it is useful for us as laypeople so we can better grasp the data. What you will notice though is how sensitive the seismometer is. Even under the windshield, it can pick up vibrations caused by the wind. And even the robotic arm moving can be easily detected, even though it's a few meters away. Detecting seismic activity is not all InSight can do. InSight was acting like a little weather station on Mars, with instruments detecting wind, air pressure, and air temperature. Even at the equator, Mars was a chilly -25 degrees Celsius, bottoming out at -100 degrees Celsius. These low temperatures are a threat to any mechanical Martian mission. The fluctuations into freezing cold can cause weathering on scientific equipment that can quickly break them. If it weren't for onboard heaters powered by InSight solar panels, InSight would have already been in big trouble. InSight was also able to detect some gusts of up to 60 kilometers per hour and low air pressures, about 6 millibar compared to Earth's 1 bar. With its first readings taken, but also with its first obstacles encountered, InSight's mission was underway to mixed fanfare. Let's jump forward now in time. Months ticked by. InSight now approached its first year mark on Mars. Scientists had been considering the problem of InSight's mole. By this point, they began to be more certain that it was not an underground rock that had stopped the mole in its tracks. Scientists had chosen this landing site especially because there were few large rocks in the area, and the mole had been designed in such a way that it should have been able to go around small rocks. The team had taken their time to think through what might be causing the problem, doing their best to create a replica of the situation on Earth using data from InSight's cameras. This isn't a perfect process, as it's impossible to perfectly mimic the lower gravitational conditions of Mars on Earth, even with replicas made from scaled-down, lighter materials. But by October 2019, they had figured out that the likely problem was indeed a lack of friction. When taking photos of the soil around the now exposed mole, they saw that the soil in this spot was different from what they'd been expecting. Although the surface you see here certainly appears loose and dusty, ideal for hammering-based digging, only a few inches deeper there appeared to be a layer of cemented soil known as duricrust. These particles of duricrust stick together more tightly, which means they won't fall into the hole the mole is creating, and thus weren't providing the friction necessary to dig deeper. Scientists hadn't realized that this type of soil was here when they picked the site for landing, as it had been hidden under the surface. But what to do about it? While InSight was equipped with a robotic arm, the top of the mole was not designed to be grabbed by this arm, so they couldn't just move it to another position. And as you can see here, there is a delicate cable designed to relay data from the mole back to InSight, which would be damaged if they just pushed down on the top of the pole with the arm. So, their first plan was to place the arm next to the digging mole, pinning the mole in place. Perhaps this would provide the friction necessary to get it started. Unfortunately, this proved to be not enough. The mole floundered in the dust, making no progress. Next, the team tried to scoop soil into the hole the mole had created. This also proved unsuccessful. More months ticked by, marking the time between each painstaking attempt. Finally, in October 2020, a full year and 8 months after the mole first started to dig, scientists attempted to push the top of the mole with the robotic arm. Although this did cause the mole to successfully bury itself, the hopes that this raised were soon dashed. Even when completely submerged by the ground, the mole would not go any deeper on its own. By the 14th of January 2021, the team gave up on the mole altogether. Although they still felt they'd learned valuable information for future missions about the nature of Martian soils. I think they'll have a new respect for duricrust going forward. Fortunately, InSight's other scientific equipment had been working much more effectively during this time. SEIS, the seismometer, was doing a much better job of providing a glimpse into Mars's inner workings. SEIS had been listening to the sounds of Mars for over 2 years by this point, and had detected over 500 different seismic events. Mars does not have tectonic plates like Earth, but it does have volcanic regions that produce quakes from time to time. And quakes produce different types of vibrations, such as P waves and S waves, that travel through the mantle at different rates. By timing the difference between when these waves arrive and listening out for their echoes as the vibrations bounce off the inner layers of Mars, it can be possible to work out Mars's internal structure, as well as learn other fascinating insights. Scientists by this point had learned 3 interesting things from all this data. First, Mars tends to have frequent but small quakes, none more powerful than magnitude 3.7. Scientists were surprised that they detected nothing more powerful given how frequently smaller quakes were happening. Perhaps Mars was more static than was expected, or perhaps they simply hadn't been lucky enough to witness a big one. It was too early to tell for certain. Second, the wind hides quakes. Because SEIS is so sensitive, even with its windshield, it could hear the vibrations caused by the wind, and sometimes this masked the vibrations of small quakes, like static on a radio. During the windier part of Mars's yearly cycle, the number of quakes appeared to go down. This was likely just because SEIS wasn't detecting them. To counter this interference, scientists formulated a plan to bury parts of the seismometer using the robotic arm scoop, as this might reduce the interference from the wind. Finally, and strangely, Mars quakes do not have surface waves. All quakes create waves. 2 of the main types, primary and secondary waves, travel through the mantle. However, normally there are also surface waves that run along the surface of the planet crust. And for some reason, these were not being detected on Mars. Scientists are still not quite sure why, but wonder if this is evidence of extensive fracturing of the upper 10 kilometers of Mars's crust, which might be diffusing the waves. To find out more, it would be necessary to wait and collect more data. However, this was more difficult than it sounds. After 2 years, time was no longer on InSight's side. InSight had reached the end of its expected mission duration, and amazingly was internally still going strong. However, an external problem had arisen. dust. Little by little, fleck by fleck, dust had built up on InSight's 2 solar panels, the 2 solar panels that provided life-preserving power to its onboard heaters. InSight had no machinery to clean its own solar panels. Scientists had hoped that dust devils would blow away this dust in cleaning events, but although some dust devils had been detected, so far, by bad luck, none had passed over InSight. By February 2021, InSight was now only collecting 27% of its potential power intake. Choked of energy-giving sunlight, InSight was beginning to feel its age. Its spirit was willing, but its power reserves were weak. Faced with this, scientists had to navigate a delicate juggling act. They needed to decide where to send InSight's dwindling power reserves: to the arm, to the size reader, the radio, or the vital heaters that kept InSight alive. And by February, Mars was entering its winter period, as well as aphelion, the time in Mars's year when it's furthest away from the Sun, and the furthest from its precious source of power. There was only one thing they could decide. They had to settle InSight down to hibernate, using its power mostly to keep its circuitry safe and warm. They hoped that come July, as Mars gets closer to the Sun again, InSight could bring its other equipment back online. Hopefully, a cleaning event would come along and the science could continue. Spring arrived. InSight awakened from its hibernation, but as it powered up its scientific systems, it still felt weak. The dust on its solar panels remained and was only getting thicker. InSight was faced with its own mortality, the growing realization that it would never get better or be at its prime again. But in spite of its diminishing power, NASA had been so impressed with InSight's data collection that they extended InSight's mission for another 2 years. InSight rose to the task. With limited time left to it and the end nearing, it threw itself into its task. Up until this point, no quake larger than a 3.7 mag had been detected. If InSight could find something like that, it would be the crowning jewel in the data it had collected. But it wouldn't be easy lasting long enough. At the start of the mission, InSight's panels were capable of producing 5,000 watt-hours each Martian day. Now, they were only producing 500 watt-hours, about enough to power an electric oven for 10 minutes. It was now a race against time to find that last big quake before InSight powered down forever. Back on Earth, its team had its back. Scientists were keen to buy InSight that little more time that it needed to hopefully find that quake. And in early July 2021, they struck upon a seemingly crazy idea. How could you remove dust from solar panels when you only had a large, clunky robotic arm with a scoop? Counterintuitively, add more dust. Specifically, to slowly trickle sand down onto the panels using InSight's scoop while the Martian winds were blowing. Hopefully, by doing this, the wind would alter the trajectory of the sand so it would bounce off the panel's edges, but as it hit the panel, it would knock dust loose, thus removing it in the process. This plan might sound crazy in theory, but incredibly, in practice, it worked. Although it wasn't much, by doing this, InSight gained an additional 30 watt-hours of energy a day. This boost in power provided InSight with an extension of life. InSight made it through the summer of 2021 and into the following year, which turned out to be a game changer. In the final year of InSight's life, past the point where it should have died, it detected its largest quakes. In May 2022, the ground rumbled. Data streamed in. InSight's size sensor detected a Mag 5 quake. Mars's lack of plate tectonics makes this a true giant of a quake for the planet. Just a few months later, InSight's end neared. In November 2022, NASA scientists started to pack down their side of the project. With the data that InSight had collected, they start collating it into a package that would be accessible to researchers around the world. They packed up the Earth-based replicas of InSight and the Martian terrain that they'd been using. They prepared to announce to the world that InSight was in the last couple of weeks of life. And on the 15th of December 2022, InSight faded out of contact. But InSight's legacy is not in the metal of its form, sitting forever on the Martian landscape. It is in the things that it learned, the knowledge it brought us. So, for one final time, what did we learn? To begin with, thanks to InSight's data, we now know that Mars does indeed have a crust, a mantle, and a core, just like on Earth. However, that crust is much thinner than we expected. It contains 2 to 3 sublayers and descends 20 to 37 kilometers deep, compared to the Earth's, which can have a thickness of 70 kilometers. Its mantle is not as hot as scientists previously believed, and descends a further 1,560 kilometers. Finally, its core is larger than scientists thought, with a radius of 1,830 kilometers. Surprisingly, it is also less dense than expected. This has led scientists to predict that it is not simply made of nickel and iron, like the Earth's core, but that it contains lighter elements like carbon, oxygen, sulfur, and hydrogen. This is a fascinating insight. It explains why the core of Mars is still molten. Much like salt's ability to reduce the freezing point of ice, which is why you see grit thrown on roads in colder weather, these lighter elements reduce the freezing point of Mars's core. It also points to the origin of the planet. These light elements must have been collected into Mars in the very earliest periods of the solar system's history, as by the time Earth was formed, these elements were not around in as great a quantity, explaining why Mars's core has them and ours doesn't. They were also found further out, indicating that Mars must have been brought closer into the Sun's gravity as time progressed, before finding the stable orbit it navigates along today. It confirms that during the early formation of Mars, all the cosmic dust that came together must have heated up and become molten, thus allowing the heavier core metals to easily sink into the planet's center. During this period, or soon after it, Mars began to experience its dynamo effect. Mars today only has a weak magnetic field compared to Earth's. Most of this field is left over as residual traces of magnetism locked into many of Mars's surface rocks. However, back in its early formation 4 billion years ago, Mars's moving metals in its core created a massive dynamo, imbuing these rocks with their magnetism. When the planet cooled, hot materials were not able to move about as quickly as they needed to keep the dynamo going. In time, Mars's dynamo ceased to be. Thanks to the data provided by InSight, scientists will have a much better idea of the timescales involved in this dynamo. This is relevant because when we talk about magnetic fields and dynamos, those can affect what the atmosphere was like. And once we understand that, we'll have a clearer picture of Mars's early habitability. InSight might give us an idea of the time period when life was most likely to form on Mars. InSight has given us an incredible amount of raw data, including a fascinating comprehension of Martian weather patterns. Yet, there are still many mysteries. Even though we now know the rough dimensions of Mars's inner structure, InSight's findings have actually disproved some previously existing theories. For instance, under a particularly volcanic region on Mars's surface, known as Tharsis, home of Olympus Mons, a volcano 2.5 times as tall as Mount Everest, there exists a hot spot of magma that feeds the volcanic processes we see in this region. Due to the absence of plate tectonics, it was unclear what was causing this hotspot, which seems to have been present, unmoving, for billions of years of Mars's history. Scientists originally thought that this hotspot was being fed by a lower mantle, but it turns out that Mars does not have a lower mantle. As such, it is back to the drawing board to explain what is causing this phenomenon. Still, these are the sorts of questions and discoveries that drive scientific endeavor. And the discoveries that InSight has given us will inform future missions for decades to come. Scientists will pore over the data, analyzing P waves and S waves, attempting to find patterns and meaning in the sounds of Mars's rumbling heartbeat. And who knows how much more we will discover as a result of this successful mission. If more comes in, I will keep you posted. But now that InSight has powered down, as it closed its eyes on the scattered clouds and dusty plains of Mars, I hope that it can rest easy. In spite of its challenges and the ups and downs, it did what it came there to do. Well, that's all we have time for today. I hope you've enjoyed listening to this slightly longer podcast on the InSight lander. I've heard from some of you that you wanted longer episodes, so let me know if this was to your liking. If you've enjoyed what you've heard, please feel free to follow us for more podcasts on other fascinating space topics. But for now, I'm Alex McColgan, and this has been Astrum. All the best, and see you next time.